Hello guys, welcome back to my channel Mason African Motives. Still working on mathematics N3. So in this platform we shall actually work on the question paper which was written in April 2019, which is an X paper. So we shall try by all means to see if possible to finish up everything so that you'll be able to revise along the line towards the exams which are ahead of time. So actually, if you're new guys, you can consider subscribing so that you won't miss any of the classes that we shall be having from Mason African Motives. So this is actually, so you know guys, the instructions and information that you're supposed to have. So mostly I want us to consider this issue of the degree of accuracy to 3 decimal places, and also guys, you must show clear working. All right, clear working. All right, let's see the first question that we are given. On question number 1.1, we are given determine the value of a if f of x, which is this f of x, is divided by x minus 2 and gives a remainder of 23. All right. From factor and remainder theorem, remember guys, I talked about this, that if you are dividing by x minus a, let's say x minus a, okay, and you have got a remainder of 3, let's just say this is what is happening. It means that you are going to find f of a. All right, you find f of a from this x minus a, you find f of a, and that f of a is going to give you a 3. That is how you answer these typical questions. All right, so in this case, where did you find this a? You simply say x minus a is equal to 0 like this, so x is equal to a. That is how you attempt such a question. So in this case, we have got x minus 2 and we have got a remainder of what? Of 23. All right, so we are dividing by x minus 2 and our remainder is 23 in this case. All right, so what does that mean? We said if we are dividing by x minus a, then f of a here, f of a should give us the remainder. So in this case, f of a, which means we are talking of 2, because we are going to say x minus 2 is equal to 0, so x is equal to 2. So it means f of 2 is going to give us the remainder of 23. If x minus 2 was a factor, let's say this was a factor, x minus 2, then f of 2 was not going to give us a remainder, it was going to give us a 0 if this was a factor. But this time it's not a factor, you equate to the remainder. So take note about this concept. So that is the idea there. So what we are going to simply do is to substitute in place of x here in our f of x, we substitute 2, then we equate to 3, because we are given that f of x is equal to x to the exponent of 3 plus ax squared minus x plus 5. This is our f of x. So in place of x, you shall substitute 2, then you equate to 23. So let's put 2 here to the exponent of 3 plus a into 2 to the exponent of 2 minus 2 plus 5. In place of x, you're substituting 2, then the answer is going to be equal to 23, like that. So what have you done? You have formulated an equation in terms of a, so you'll be able now to solve for a. Remember, the question needs us to find the value of a, so that's going to be 2 to the exponent of 3, which is 8, to the exponent of 2, which is 4a, minus 2 plus 5 is equal to 23. So what you can do is you can combine these numbers, 8 minus 2 plus 5, which is going to give you 11. So we've got plus 11 equal to 23. Then transpose this, it will be minus 11. So 4a is 23 minus 11, which is 12. So to find a, divide by 4 by 4, so your a is going to be 3. So that is the idea there. So the major thing, guys, that we are talking about here is that whenever you are given a certain expression which is being divided and you are given the remainder, you equate like this. Okay, this is what you do. Do not use -2, you use a positive, which means if it was x plus 2 like this, you were going to use f of -2. That is for what you simply do. So as you can see, it's pretty easy. You just need to work out as much questions as possible. Then on 1.21, yeah, we had that question which has got 7 marks. Let's see how we were supposed to obtain those 7 marks there. How are we supposed to obtain those 7 marks? So this is what we had actually. Let's see, because I had written here so that at least we just work out direct the question. So as we can see there, we've got a lot of things mixed and so forth that we are supposed to work out. And what can we do? Let's start with the first part. We have got y into x plus y squared plus y plus x, like this. This is what we have here. All right, so let's just try and simplify. Maybe we can obtain something, because here this does not make sense, guys. So let's just expand and see what we have. That's yx, y and y, which is y to the exponent of 3. Take note, you are going to add the exponents, plus y times y, which is y squared. Okay, this x is out of the bracket, so it's just going to be plus x. It's not going to be affected by this y because it's not part of the bracket, this one. Now we can see something here, because we can actually group, because these are 1, 2, 3, 4 terms. Remember, if you have got 4 terms, you can factorize by grouping. So let's just try and group our terms. We've got this part with x. Let's group this part together like this. All right, then this part with y only, let's just write it aside like this. So we have taken these 2 terms with x together, these 2 terms with x, then the other terms with y together like that, so that you will be able to group into 2 like this. Remember, this is by grouping, where you need to group 2 terms like that. You factor out what is common here. Remember, we want to factorize. That is why we are doing this. So if I factor out x like this, because it's common, I'm going to be left with y here, yx divided by x. That's y plus x divided by x. As you can see, this will cancel, but you don't cancel, you know that it will cancel, which is going to give you a 1 there. From these 2, what is common? What is our highest common factor? Remember, the highest common factor, when you've got same letters like this, you take the one with the smallest exponent. So your highest common factor is y squared with the smallest exponent. Then you do the same, you divide y to the exponent of 3 divided by y squared. So it's just like this, to the exponent of 3 divided by y squared. So as you can see, the base are the same. You subtract the exponent, so it's 3 minus 2, which is 1, which is same as y, plus y squared divided by y squared. So as you can see, these are the same, so they can cancel to give us a plus 1. You don't cancel, you just assume doing that. All right, now as we can see, these 2 brackets are the same. These 2 brackets are the same. Remember, you factor out the common bracket, then you'll be left with x here. You're going to be left with y squared like this. All right, so take note, guys, you're working. So this is the answer that we need from that bracket, which is y plus 1 into x, whatever that we have. So that is what we are going to have here. So we obtained y plus 1 into that is x plus y squared. All right, that's x plus y squared like this. All right, Then here there is nothing that we can do, we just have to rewrite as it is, which is y plus 1. And another thing, remember that here we are dividing. Okay, so whenever you are dividing, you have to introduce multiplication, and the moment you multiply, you are going to invert the second fraction, which means this is going to interchange. This will be written on top and this will be written down. All right, so if this is going to be written on top, which means we shall have y squared minus x squared on top, and we have to factorize it, which is a difference of two squares. As we can see, these two are squared, so it's y plus x into y minus x. This is what you're going to have from the difference of two squares, because we said this is going to be written on top the moment you introduce multiplication. So it will be y plus x into y minus x, like this. Everything over. This is the part that you're supposed to write down here now. So this part here is the one that you're going to write down. But instead of rewriting this as it is, let's factorize it. All right. So we have got this part here. Let me just write it. It is 4y squared minus 3yx minus 7x squared. This is what we have here. So how can we factorize such type of an expression? What can we do to factorize such type of an expression? All right, we are going to apply the longer way of factorization, because you've got a quadratic, so you're going to multiply the first term and the last term. All right, take note guys, because here the coefficient of y squared or x squared is not 1, so you have to do the longer way. So if we multiply these two terms, that's 4 times minus 7, which is minus 28 y squared x squared. So these two, you just combine them like that. So what you need are two terms. You need two terms that you are going to multiply, which are the factors of minus 28 actually, but when you add them, they will give you the middle term, which is minus 3yx. So which terms are we talking about here? Which are the numbers? All right, let's just try our numbers aside. Since we've got 28 and we've got these two numbers, which is 7 and 4, there's something that has to do with 28 there and 3. How can we obtain 3? It's supposed to be 7 minus this. But to obtain minus 3, it's supposed to be bigger number with a negative and the smaller number with a positive, because if you multiply negative times 4, negative 7 times 4, that's negative 28. If you add negative 7 plus 4, it's going to give you minus 3. So since this is y squared x squared, so it's going to be yx like this. So that's how you put it. So it's best for you to start working with the numbers, then you put on the letters after that. All right, so here since this term is having 4y squared, I'm gonna start with this. All right, so when you're substituting, remember you have to substitute these two terms into this middle term, but because here I'm already having a 4, so I'm going to start with this, a positive, this one. So plus 4yx minus 7yx. So I haven't changed anything, but I have just tried to write these numbers with 4 together, these numbers with 7 together. At least it can make the factorization easier. All right, now let's factorize, because remember, once you've got 4 terms like this, because it's 1, 2, 3, 4, you have to group them into 2. Just like what we did on the previous part, you factor out the highest common factor between these two brackets, between the two terms, which is, we've got 4 and 4, y and y here. So you're going to take the one with the smallest exponent, which is y. That is our common factor. Remember, x is not common here. So you're going to divide 4y squared, divide by 4y, that's 4 and 4, y squared, and y, which is y, because 4 and 4 will cancel, plus 4yx divided by 4y. As you can see, 4y and 4y will cancel. You remain with x, so it's going to be plus x like this. Now you have to factor out from these two terms a common factor which will make these two brackets to be the same. So what is common? Let's start with the numbers minus 7, minus 7. So we have to factor out minus 7. We have got x and x here. So we're going to factor out x, the one with the smallest exponent, which is x. That is our highest common factor there. So now let's divide minus 7yx divided by minus 7x. As you can see, minus 7x minus 7x will cancel. You're going to remain with positive y there because minus 7 will cancel. X and x will cancel. Okay, minus 7 and minus 7 will cancel. That's a plus. So you're going to be left with x squared divided by x, which is x like this. So as we can see, these two brackets are the same. Now, we said we are going to factor out the common bracket, okay, which is this common bracket. Then we are going to be left with these two, which is 4y minus 7x, like this. Take note, guys, your factorization, and please take note how you factorize this part. Take note. So this is what you're going to have, which is we write it here because remember we said this, we are going to write it down. So that is where we are going to write it down here, which is y plus x into 4y minus 7x, like this. All right, times this is already under multiplication, so there's nothing that you're going to do. We just check, do we have anything common here? We do not have, so we're just gonna rewrite as it is 4y minus 7x over x plus y squared. There's nothing common again there. So that's what we have, guys. So what are we going to do? We have to cancel. As long it is the relationship between the numerator and denominator, you can cancel. So you can cancel y plus 1 and y plus 1. They can cancel. Y plus x can cancel. All right, which else that we can cancel here? 4y minus 7x can cancel. All right, what else do we have? We have got this one, x plus y squared can cancel. So what am I going to be left with? As we can see on top, you are left with this part of y minus x. So we are left with y minus x over here. Down here we are just left with 1 because there's nothing here, so it's just 1. So which simply means it's y minus x, just like 3 over 1 is equal to 3. So y minus x over 1 is the same as also y minus x. So guys, that's how you perform the factorizations and how you cancel out the fractions, so forth and so forth. So you just need to revise, guys, as much questions as possible, especially factorization is the major part that plays a bigger role here. So you have to know your factorization very well. All right. Another part we are given on 1.22 is to simplify again this part here. All right, so this time we are adding. We are not multiplying or dividing. We are adding, and these are the fractions here that we are having. All right, so what are we going to do? Remember, when you are given such type of expressions, we have to try by all means to factorize. And as we can see, this is the only part that we can actually do our factorization. So let's just rewrite the other part as it is. So this is going to be 6 over x minus 2 plus, okay, guys, 2 plus x and x plus 2 are just the same, just like 1 plus 2 and 2 plus 1 is just one and the same thing. So you can write this as x plus 2, at least it can make sense, minus 9x minus 5 over, then this we can factorize, at least this one we can factorize direct because the coefficient of x squared is minus 1. So we just need factors of what? Of minus 6. So we need factors of minus 6. that we are going to add to obtain plus 1. And which factors are these? Let's try 3 and minus 2. Does this make sense? 3 times minus 2, that's minus 6. If we add, that's 1 there, yes. So it's 3 and minus 2, so it's x plus 3, x minus 2, like that, exactly. So once you're at this stage, remember you are adding at the same time you're subtracting. So you have to find the LCD of everything, which is the LCM of everything. Alright, that's the LCM of everything. So remember LCM, you have to take everything that is there. So you've got this x minus 2, you have to take this x minus 2. It's appearing here, we have got it here, we also have it here, so it's appearing once, so we just take it because it's common here, so you just take it once. All right, then we've got x plus 2 and x plus 3, like this. All right, so this is our LCD or our LCM. Now, how are we going to go about it? Remember, we have to divide LCD, which is your LCM, divide by the denominator here, which is x minus 2. So as you can see, this x minus 2, this one, and this one will cancel. But you don't cancel, you just assume cancelling this and this. So you're going to be left with 6 into these two brackets because this has cancelled each other with this. So you're going to be left with x plus 2 and x plus 3, like this. All right, plus 3 multiplied by whatever that you're going to have. So you divide again your LCD, this one, this is your LCD, divide by x plus 2. So as you can see, x plus 2 will cancel. So you're going to be left with x minus 2. Here you're going to be left with x plus 3. So you don't cancel, you just assume cancelling, but you don't cancel. All right, minus, this is our expression, so let's just write this. It's supposed to be in a bracket because it's minus, and this is 9x minus 5. It's an expression, so you write it like this, minus 9x minus 5 in a bracket like this. Okay, times whatever that you're going to have. So you divide LCD, divide by this denominator here. So x plus 3 and x plus 3 will cancel. X minus 2 will cancel. So which means you are going to be left with x plus 2 because this and this will cancel, this and this will cancel. So you'll be left with x plus 2, like this. So that's how you go about it, guys. Whatever that you get after dividing, you multiply it to the numerator. Whatever that you get, you multiply it to the numerator. So as we can see, there is a job that is supposed to be done here on the numerator because here we are separated by a plus. So we have to simplify this part here of 6 into x plus 2 into x plus 3. We have to simplify that one first. All right, so how are we going to go about it? We can actually maybe just expand this aside, x plus 2 into x plus 3. So remember, you have a space that you are supposed to do your working separately. So you can do such working like expanding brackets separately. This is going to be x and x, which is x squared, x and 3, which is 3x. Thus here we move on to 2 and x, which is 2x, 2 times 3, which is 6. So you're going to add, which is x squared plus 5x plus 6. So this is what you're obtaining, but it's supposed to be multiplied by what? By 6. So it's going to be 6 into x squared plus 5x plus 6. So everything that we have there, we are going to multiply it to 6. That is what it means here. Then we have got plus 3. We are going to multiply whatever that you're going to obtain from x minus 2 and x plus 3. We have got x minus 2, x plus 3, expand that one separately. That's x and x, which is x squared, x and 3, which is 3x, minus 2 and x, which is minus 2x, minus 2 and 3, which is minus 6. Because take note, minus and a plus, it's a minus. So you're gonna have x squared 3 minus 2, which is x minus 6, like this. So it's gonna be x squared plus x minus 6, x squared plus x minus 6, like this, which is to be multiplied with 3. Okay, we move on. There's a negative here, which is going to multiply the resultant of these two brackets here of 9x minus 5. So that's 9x minus 5 and x plus 2. All right, so you just have to expand this separately. That's 9 and x, which is 9x squared. 9x and 2, 9 times 2 is 18, so it's 18x. All right, minus 5 times x, which is minus 5x, minus 5 and 2, which is actually minus 10. All right, so we're gonna collect like terms here, which is 18 minus 5, which is 13. So this is going to give us 13x minus 10. All right, so take note, 9x squared plus 13x minus 10, whatever that you obtain there, here is the one that you're going to write. Then everything over, you don't leave these brackets, you have to write them again and again up to the last part. So you write this. All right, this is what you're going to have. This is x plus 3, sorry. Now we have to expand brackets so that we can be able to collect like terms and simplify them. That's 6 times x, which is 6x squared. 6 times 5, which is 30x. 6 times 6, which is 36. Like that. All right, we are done. This bracket, you've expanded up to where the bracket ends. So the bracket ends here. Plus, we move on to 3. It expands this bracket up to here. So 3 times x squared, which is 3x squared. 3 times x, which is 3x. 3 times minus 6, which is minus 18, because this is a plus. So you are done. You move on to this. So what is multiplying this bracket? It's actually minus 1. There's a minus there. So it's like minus 1. So it's minus 1 times 9 x squared, which is minus 9x squared, minus and a plus is minus 13x, minus and a minus, which is going to be plus 10, like this. All right, everything over, you do not leave this. X minus 2 into x plus 2 into x plus 3. Now we have to collect like terms. So let's collect like terms, guys. Let's start with x squared. This one with x squared. So it's 6x squared plus 3x squared minus 9x squared. So 6 plus 3, that's 9. 9 minus 9, that's S0. So this one will cancel. That's S0. There's nothing there. All right, we move on to the part with x. So it's 30. All right, 30x plus 3x, which is actually 33x, minus 13x, which is 33 minus 13, which is 20x. So this is gonna give us 20x here, where there is x. Remember, the part of x squared cancelled, so we are just going to be left with 20x. We move on to the constants. We have got 36 minus 18, which is actually 18, then plus 10, which is 28. 18 plus 10, which is 28. So we're going to have 28 like this. Everything over the brackets as they are. These brackets, 3 brackets as they are, you write them as they are, which is x minus 2 into x plus 2 into x plus 3. So you write those brackets as they are. These brackets here in the denominator here, you just repeat them as they are. So that's what you're going to have. But since we do not know what is going to happen here, we have to try to factorize what is common here. So we've got 4, 4 there. You can factor out 4, which is 20x divided by 4, which is 5x. 28 divided by 4, which is 7. So why actually do you have to factorize? This is the reason, guys. You are in exam and you do not know what is going to happen between these brackets, because let's say you factorize, I'm just saying this, let's say you factorized and you obtained something like this, right? Maybe this is what you obtained after factorizing. It is going to help you to see a condition of having brackets which are the same, like this part of x plus 2 and x plus 2. It can cancel when such condition occurs. But in this case, we do not have such. This bracket cannot cancel to any of these both. They are not the same. So it means our answer can be left at this stage, or you can also leave it at that stage. That is how this was all about. So as you can see, guys, it's all about the basics of your factorization, how you do your factorization. That is what matters the most. All right, then we are given the log to solve. Log x plus 1 in base 2, which is equal to log 2 in base of x plus 1. So how are we going to go about it here? Okay, let's see what we can do, because actually this part we can see that these bases are not the same. So we know that we can do the interchange of bases here using this concept of 1 over log a base b, which gives us log b base a, where you interchange these numbers. So I can actually do that to make sure that these two are the same. So I can have this as log x plus 1 in base 2, which is equal to, so for me to write this log as this one in terms of base 2, I'm going to introduce 1 over, so it is going to be 1 over like this. The moment I introduce 1 over, I interchange these two numbers, so it's going to be log x plus 1 in place of 2, so it's going to be x plus 1, then 2 in place of x plus 1, so it will be base 2 like this. So as we can see, we are now having the same thing here, log x plus 1 in base 2, log x plus 1 in base 2, even though this is in the denominator. So what you're going to do is that this is a fraction, so there's no way we have to write this also as a fraction. Remember, every whole number can be written as a fraction like this. 2 over 1 is same as 2, so which means the same as log over 1 does not change anything. But this can allow us now to do what? To do the cross multiplication. So we can cross multiply. So we are multiplying the logs which are the same, just like multiplying x times x. We know that that one gives you x squared. So that is the concept. So this log x plus 1 in base 2 times log x plus 1 in base 2 is actually going to give us log x plus 1 like this in base 2. Everything to the exponent, you square that log, because this part and this part are the same. So just like x times x is x squared. So that is the concept there. Then we've got 1 times 1, which is 1. Yes, 1 times 1, guys. That one we can't write it as 1 squared. We know that 1 squared is 1. So there you have to just leave it like that. Okay, there's no way. You have to just write it like that. Now you are at this stage where you are supposed to solve for this log, where there are so many options or so many ways that you can actually do this. All right, you can choose to introduce the square root here because you're given a squared. So you can choose to introduce a square root like this, so that you can remove this squared, which is going to be log x plus 1 in base 2 like this. Okay, let me just try and adjust this side. All right, I don't know what happened there. So it's going to be log x plus 1 in base 2 like this, which is equivalent. We know that square root of any number is plus or minus, so this will be plus or minus 1. So that means we have got two solutions which are going to be expected here. The one which is a plus and the other one which is a minus. So that means we are going to have two solutions. Log x plus 1, the one that we have in base 2, this one, being equal to plus 1 and another one equal to minus 1. So it's going to be equal to 1, or another one of log x plus 1 in base 2 being equivalent to minus 1, like that. So that is the whole concept of the question. So now, how am I going to solve when I am at this stage? Remember, here you've got this option where you can transpose from log form to exponent form. Remember, I told you guys about log a base b, which is equal to c, where I said this one can be transformed to exponent form, which is a is equal to b to the exponent of c. So it's a, this is your a, b, this is your b to the exponent of c, like this. So this is your a here. So you're going to have it as x plus 1 is equal to 2 to the exponent of 1, which is just 2. Or here, this is your a, which is x plus 1, which is equal to b to the exponent of c, that is 2 to the exponent of negative 1. So if you know this concept, you can be able to solve a lot of questions with this. So x plus 1 is equivalent to 2 to the exponent of 1, which is actually 2. So where can I have x transpose here? It's going to be minus 1. So your x is 2 minus 1, which is 1. Or here, x plus 1 is equivalent to 2 to the exponent of minus 1. We know this one is 1 over 2 from our laws of exponents. Then we transpose, this is going to be minus 1. So x is going to be half minus 1, which is minus half. Remember, half minus 1, that's minus half. So these are the values of x that we are obtaining. X, which is equal to 1, and x, which is equivalent to minus half. So what you do is that you cross-check them if they are going to maintain the two logarithms here, so that you see are they the actual values of x. But these ones actually they are going to maintain, because minus half plus 1 is going to give us half, so it's going to be a positive. So this one is going to be part of answer, and also this one is a positive, so it's going to be definitely part of the answer. So that is what we had from this question. So take note, guys, how they ask these questions. Must be very, very careful. All right, another part is to simplify the following expressions. All right, so we've got on 2.21, that is the expression that we were given. So how can we go about it to simplify this type of an expression? Okay, so let's check, guys, if we have got anything that is common that we can actually maybe simplify, if there is anything common. All right, here there is something common, because we have to factorize if possible. So we can actually factor out here b to the exponent, because remember, when you factorize, guys, you take the one with the smallest exponent. This one is same as 1. So between half and 1, which one is the smallest? Half is the smallest. So you factor out b to the exponent of half, like this. All right, which means if I factor out b to the exponent of half, I'm going to be left with b, and b will cancel. I'm going to be left with a to the exponent of a half, like this. Minus, remember, when you factor out, you divide. So you're going to divide b to the exponent of 1 divide by b to the x. It's like this: b to the exponent of 1 divide by b to the exponent of a half. Remember, when you divide the base which are the same, you subtract the exponent. So it will be b to the exponent of 1 minus half, which is a half. So this is what you're going to obtain after factoring out this. You're going to obtain b to the exponent of a half, like this. All right, everything over a minus b. So let's just write this. Maybe okay, I'll talk about it later on. Now, before you talk about the introduction of the multiplication, because here we have to interchange, but as you can see, this is not a complete fraction. So let's first simplify so that we can see which fraction are we going to invert, because this is supposed to be combined first. So forget about introducing multiplication for now. So for now we have to add the two. 1 plus a to the exponent of half over b to the exponent of a half, like this. How can we add these two fractions? Okay, remember, when you are adding, we have to find the LCM or the LCD of these two, which is b to the exponent of a half, because it's just 1 and b here. So remember, what you do is going to be 1 times, you divide b to the exponent of half times 1, divide by 1, which is b to the exponent of half. This is not going to change, plus a to the exponent of half there on top, multiply by, you divide b to the exponent of half, divide by b to the exponent of, so this and this will cancel, which is going to give you a 1. But you don't cancel, you just know that it's going to cancel like this. So as we can see, this is going to be b to the exponent of half plus 1 times this is going to be a to the exponent of half over b to the exponent of a half, like that. So this is what you're going to have here after adding these two under the bracket. So this is, we said, b to the exponent of half plus a to the exponent of half over b to the exponent of a half, like this. But everything, take note guys, is to be raised to the exponent of -1. All right, so there are actually two things that are occurring here. 1, there's a division. 2, there's an exponent of -1. We know that if you are given x over y like this to the exponent of -1, it gives us y over x. You just interchange the two. Okay, so this is what you're going to do. B to the exponent of half into a to the exponent of half minus b to the exponent of a half, like this. All right, then the other thing that you are supposed to have is that from this a minus b, this one, we are supposed also to write in terms of this a to the exponent of half. So what can we do? Okay, we'll talk about that, because we have got a minus b. Can we factorize this, guys? Can this be factorized? Is it possible? All right, let's see. We know that to factorize, if it is a difference of two squares, we must have an even exponent. We must have an even number here. So this is actually an even number, 1 and 1. These are even numbers. What I'm trying to say is, if we can raise to the exponent of 2, remember we have to write this in terms of to the exponent of 2. All right, minus b to the exponent of 2. Let's just put this way, to the exponent of 2. But we are talking for even numbers, all right, because of being a perfect square. So this one here is the one that we want, this one, from these two, because we know that, remember guys, what you need is to achieve this x squared minus y squared from a difference of two squares. You know that it gives you x plus y into x minus y, like this. Okay, so this is what we need to have it in terms of squared. That is why I have to put this squared here, so that it gives us a difference of two squares. But how can we write this one in terms of this exponent of 2 so that it will go back to this one? We want to write in terms of another number, and it gives us the same one. So which number is that? Definitely it's a half, because 2 times a half, like this, it gives us 1. So you haven't changed anything. So this can be written as a to the exponent of a half, like this, to the exponent of 2, because if you multiply this, you get a 1. The same with b is going to be b to the exponent of a half, because if you multiply this, you're going to obtain a 1 again. So once you have written this in terms of to the exponent of 2 like this, it means it's now a difference of two squares, just like this. So we have got this part here of a to the exponent of half plus this part here of b to the exponent of a half, like this, into the other bracket, which is going to subtract. So the other bracket is going to subtract. We know that concept of difference of two squares. So that means this part here is the one which is going to be replacing a minus b. So we are going to replace our a minus b here with this part, a to the exponent of half plus b to the exponent of half into a to the exponent of half minus b to the exponent of a half, like this. So take note, guys, we are still under division because here there is an exponent, so we have to know what are we going to invert. So we are going to we are still under division. Under division. So remember what I said about this concept, that if you are given x over y to the exponent of -1, you interchange these two. So you are going to interchange these two. So it's going to be b to the exponent of half on top over this one below, which is b to the exponent of half plus a to the exponent of half, like this. So you have removed this exponent of -1, just like this part. It's no longer there. All right, now that's where we can see that, okay, we are to introduce multiplication now. So but before we do that, maybe we can just cancel some of the things, because there's no need of rewriting these two, because we can see that these are already multiplying each other. So these can cancel each other. They have no problem. These two can cancel each other because there's no need for us to keep on rewriting these. Okay, but these ones, we just rewrite as they are: b to the exponent of half over a to the exponent of a half plus b to the exponent of a half, like this. Remember, we want to introduce multiplication. The moment you introduce multiplication, remember what happens? You invert the second fraction. So we are inverting this fraction again. So this will be written on top: b to the exponent of half plus a to the exponent of half over, this is going to be written down, which is b to the exponent of a half, like this. All right, so remember, guys, that we are multiplying, so we can cancel now whatever that we want to cancel, as long as possible to cancel, as long as the numerator and the denominator, just like what I did, because it was the numerator and we can cancel. And here these two are the same here, so these two can actually cancel, because as you can see, this is b positive, 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 so they can cancel. So you're going to be left with 1 over 1, which is actually nothing else but a 1. So that is where this whole part, guys, was taking us. Just imagine, guys, all this part, that is where it is taking us to a 1, just like that. So that's how they ask some of these questions. So you just need to be careful with the typical question that you'll be given, something like that. All right, so I want to see another question that we were given. All right, which is this time on logarithms, and we have got 4 marks for that, which is on logarithms. So let's see what we are given on 2.22, which is to simplify. So there, as we can see, we do not have something that is common here, but maybe we can just try and simplify in simplest form these numbers, because we do not have anything common. So it's a trial and error that we're gonna do. So 16 in its simplest form, we can choose to write them in terms of 2 is the simplest form actually. So 16 in terms of 2, that's 2 to the exponent of 4. If you multiply 2 times 2 times 2 4 times, that's 16. Minus 4 in terms of 2, that's 2 to the exponent of 2 in base b. Okay, everything over, you move on to 4 again in base of 2. We say this one is 2 to the exponent of 2 in base a. Minus 2 is already in simplest form, so this can be just 2 to the exponent of 1 in base, because it's already in simplest form, so you can just write it as 2 to the exponent of what? Of 1. All right, so in this case, we are going to see that we you have the laws of exponents of logarithms, which is from this law. I talked about this law a lot of times, if you still remember, which is going to give us log m to the exponent of p, where you're going to raise this to the exponent, which means if you are given it as an exponent like this, you can actually write with p log m multiplying the log just like this. So which means we can multiply by 4 to the log. So this is going to be like this. It will be 4 log 2 base a. So like this, if we drop this exponent here, it is going to be 4 log 2 base a like this, minus if we drop this number here, it is going to be 2 log 2 base b like this. Okay, we do the same here. We drop this number, it's going to be 2 log 2 base a like that, minus here it's just 1, it's just like a 1. So if we drop it, just like 1 log 2 base b, but there's no effect on that one. All right, so at this stage still we are nowhere. Where are we heading? Where are we gonna reach? But here there's something that is common. Actually 2 is common, so if I factor out 2, maybe a magic can happen there. So if we factor out these 2, what are we going to have? It's going to be 4 divided by 2, which is 2. So we're going to be left with 2 here. So it's going to be 2 log, everything remains as it is, log 2 base a like this. And here if we factor out 2, it's going to be 2 divided by 2, which is actually minus 1, because this is 2 and 2, which is minus 1. This repeats as it is, which is log 2 base b. All right, but down here we do not have anything that is common here. Maybe 1 is the common, but there's no need. Maybe you can just write a 1, but there's nothing that is common, so it's going to be as it is. Just rewrite as it is, because there's nothing that is common there. So you just have to rewrite as it is. So now, as you can see, these 2 are actually the same. This one and this one, they are the same throughout, so they can cancel each other, and you'll be left with 2 over 1, which is actually nothing but a 2. So as we can see, guys, that's how these questions might be given and how you're supposed to actually attempt these questions. They will be given in a way like this, and this is how you attempt them. All right, let's see this part now on question number 3. So on question number 3, we are given a condition that when 1 is added to the numerator and the denominator of a fraction, the fraction becomes a half. And when 2 is subtracted from the numerator and the denominator of the same fraction, take note, we are talking about a certain fraction, the fraction becomes 1 over 5. Determine the fraction. All right. So actually here, all these statements, they are centered on a fraction. This is where they are centered on a fraction, which we do not know. Okay, so let the fraction be equal to x over y. We do not know this fraction, or whatever letters that you want. Maybe you can write your fraction as m over n, p over q, as long as it's a fraction. A fraction just need to have the numerator and the denominator. That is a fraction. So this is our fraction, guys. So now when the concept is, when 1 is added, take note, where is 1 added? It is added to the numerator and the denominator of a fraction. So 1 was added, and it was not only added to the fraction, it was added to both the numerator and the denominator. So this is what we are going to have. This is our fraction. We add 1 to the numerator like this. This is our numerator. We add 1. We add 1 to the denominator. This is 1. What are we going to have? The fraction becomes half. So this fraction is going to give us a half if we do this. All right, that's a condition that we're given. All right, then when 2 is subtracted from the numerator and the denominator, just like what we did, from the same fraction, the fraction is going to be 1 over 5. So when we subtract 2, so now we subtract 2, that's x minus 2 over, on the denominator we do the same, we subtract 2 like this. The fraction is going to be 1 over 5. We are told the fraction becomes 1 over 5. So determine the fraction, and you've got 6 marks for that. All right. What are we going to do, guys? We have got 2 fractions here. So actually you have to solve. It's like you're having 2 equations that are appearing here. So you have to solve, because once you can obtain the value of x and the value of y, therefore you just write them as a what? As a fraction. So you just need to find the value of x and the value of y. So let's start with the first equation. Let's rewrite that first equation in a simplified manner. That's x plus 1 over y plus 1 is equal to 1 over 2. So what can we do? We can remove the fraction by cross multiplying, so at least we can simplify this. So that's 2 times x, which is 2x, 2 times 1, which is 2. Then this one you multiply by 1, 1 times y, which is 1, 1 times 1, which is 1, like that. So you can just maybe simplify, make y the subject or whatever. So you can just take this 2 to the other side. We're gonna have 2x to be 2 minus 1, because it was a plus. So 2 minus 1, that's 1, which is equal to y. So this is a simplified equation from our equation 1. All right. We do the same on our equation 2. Just do the same cross multiply here. That's 5 times x, which is 5x. 5 times minus 2, which is minus 10. Then 1 times this one, it just multiplies as it is, which is y minus 2. So you can do the same again. Make y the subject, just transpose this to the other side. So you can have 5x minus 10. It will be like this, minus 10 plus 2, which is actually minus 8. So you're going to obtain minus 8, which is equal to y. So guys, this is still from our equation 2, so it's like nothing that we have done. So 5x minus 8 is equal to y. This is still from our equation 2. So we want to solve for x and y, guys. And as you can see, this statement here, we are saying y is equal to 2x plus 1. The same y is equal to 5x minus 8. What does this mean to you, guys? Does this bring something to you? This must bring something to us, because this is the same value of y. Like we can say y is equal to 2, and definitely y can't be equal to any number but 2. So these two, they are actually equal. So it means these two, they are actually equal. 2x plus 1 is definitely equal to what? 5x minus 8, because these are expressions for y. So if these expressions represent y, therefore they're equal. Or you can just do substitution to say, since y is the subject from equation 1, I'm going to substitute in place of y. Still, we are going to form the same thing. All right. Then we solve for x, collect like terms. So this is going to be minus 8 to this side, which is going to be plus 8. 1 plus 8, which is 9, is equal to 2x. To this side is going to be 5x minus 2x, which is 3x. Divide by 3 by 3. Right. So our x is going to be 3. So that's the value of x that we are obtaining in this case. So to find the value of y, you're going to substitute into any one of the given equations that we have here. Remember, we said y is 2x plus 1, whatever that you have. So you've got y, which is equal to 2x plus 1, and your x is 3. So which means your y is going to be 2 times 3, which is 6, plus 1, which is 7. So this is the value of y that you're obtaining. But remember, the question is to determine the fraction. So what is the fraction? Remember, we said let our fraction be x over y, like this. This is our fraction, x over y. So you've got the value of x, which is our x is 3 and our y is 7. So therefore the fraction is 3 over 7, just like what we said. So that's how, guys, some of these questions, that's how they ask them and what you're supposed to do when attempting these questions. Okay, make R to be the subject of the formula on 3.2, and this is actually 3 marks. that's Rmn everything over Re plus Ma, okay, which is equal to 1. So we want to make R to be the subject there. So what are we supposed to do? Let's see, guys, the type of fraction. We have given a fraction, so at least we also want to make R to be the subject. We can just write this as 1 over 1 so that we can clear fractions by cross multiplying 1 times Rm, which is Rmn, equal to 1 times this part here, which is Re plus Ma. This is what you're going to have. All right. Now at this stage, you want to make R to be the subject, but you have got R on this part and also on this part. So you transpose to one side of the equation, which is Rmn minus, if you transpose this to the other side, it's going to be minus Re, which is equal to Ma. So you have taken terms with R to one side of the equation so that you can factor out R which is common. So you've got R here and R here, so you can factor it out. That is to factorize. So if you factorize R here, it's going to be Rmn divided by R, which is Mn. You're going to be left with Mn minus Re divided by R. This will cancel. You're going to be left with E like this, which is equal to Ma. And we want to make R to be the subject, so what are we going to do? We divide by the bracket of Mn minus E, divide by the bracket of Mn minus E, both sides. We have to divide. All right, so therefore our R is going to be Ma over Mn minus E, like this. This is your R now as the subject of the formula from that. So as we can see, guys, these are the stages that you were supposed to take there. You have to be just very, very careful with each and every step that you take. All right, then another part here is to solve this equation by completing the square. So for x, using completing the square, that's 3.3. We have got 4x squared, which is equal to 4x plus 1. Remember, whenever you're working with completing the square, you have to make sure that we put the terms of x to one side of the equation. That's 4x squared minus 4x is equal to 1. That one you can just leave it there. So you have to make sure that the coefficient of x squared here is positive. It's positive 1. So we can divide each and every term by 4 so that this can be positive 1 x squared. So we are going to be left with x squared, divide this, which is minus x, which is equal to 1 over 4. Remember, this is where you complete the square. And how do you complete the square? You find half the coefficient of x, of which the coefficient of x is minus 1. So you find half of minus 1, then you square it. Why do we have to find this? The half of minus 1 squared, because we need to add it both sides. So this is going to be minus half squared, which you can write it as 1 over 4, or you can just choose write it as minus 1 like this, but you have to add that square both sides. So you're going to add x squared minus 1x, which is just minus x. Then we add the square, which is plus minus half, which is our square like this, which is equal to, you do the same on whatever you do on the left hand side, you do it on the right hand side. So this is going to be 1 over 4 plus the square, which is this minus 1 over 2 squared, or you can just write it as 1 over 4, depend with what you want. All right, so this is what you're going to happen. Once this is written in this form, you take these two terms which are being raised to the exponent of 2, this one, the first term and the last term, you combine them in a bracket. That's x minus half, like this, everything to the exponent of 2. You have factorized this. So to factorize this, you just take the first term and the last term, you put them in a bracket, then you square. So you're factorized. Okay, then here you add these two, 1 over 4 plus minus 1 over 2 squared. You add them together. Okay, combine them together, and this is gonna give you a 1. Is it a 1 or it's a half? because it's gonna be 2 over 4, which is a half. Yeah, so this is a half here, like that. So now you have to solve. Okay, how do you remove this square? You introduce the square root both sides, introduce square root both sides, so this gonna automatically cancel. You are left with x minus half. So x minus half is equivalent to the square root of half, which we know that square root of any number is plus or minus. So we are going to have plus square root of a half in this case, or x minus a half, which is equal to minus the square root of a half, because our answer is a plus and another one is a minus. All right, so that means x is equivalent to minus half to this side, it's a plus, so it is going to be half plus square root of 1 over 2 like this, or x is equivalent to minus half to this side, it's a plus, so it's plus half minus square root of 1 over 2. Take note, guys, this is one term, this one, so make sure that when you use your calculator you use it properly. It's not part of this half, so once you use a calculator, this is gonna give you 1,207,106, something like that, which you can round to 3 decimal places, which is 123, which is 207, or here x is going to be negative 0,20 something like that, of which to 3 decimal places is going to be negative 0,207. All right, so this is what we are going to have for the values of x. So as you can see, guys, by completing the square, it's something that you have to learn, and I always say that these methods you're supposed to know all of them: factorization, quadratic formula, and also the completing the square method. You're supposed to know all of these methods. All right, then on question number 4, there we've got nothing. Given that calculate the value of p and q if m is the midpoint. So as you can see, you're given a Cartesian plane and m is the midpoint. So remember, guys, you'll be having your formula sheet. Do I have it here? But there you can just use your formula sheet. Actually, let me just show you 1 or 2 here. Whenever you are working with a straight line, okay, they have given you everything about a straight line here. This is a straight line. The midpoint, the angle of inclination, the distance, everything is there here. All right, so now let's attempt the question. So the question is, we have got the point M, which is the midpoint, and we saw that the midpoint there is given by, so in this case, to find the values of p and q, we are going to use the midpoint concept. So using the midpoint concept, remember that our midpoint is given by this. This is our m, which is our midpoint from our, okay, let me show you. This is the formula that I want here. This is the formula that you're supposed to write, okay? x1 plus x2 over 2 plus y not plus, that's a separation of points. Sorry guys for that. This is now, the mind is tired now. All right, anyways, that's what we have. That's our midpoint, and our midpoint m is this one, which is minus 7 over 2p. So this is actually representing our m, which is minus 7 over 2p, like this. So what am I going to do? I'm going now to substitute the x1 and the whatever that we have from the point, because this is the midpoint of the line AB. So this is where you have your x1, because you've got x and y there, from the point A, which is Q3. So you've got x1 and y1 here, and our point B, which is minus 8 minus 1, we have got our x2, y2 there. So since this is the midpoint, okay, so x1, it's q plus minus 8, all right, which is our x2. Q plus minus 8, which is q minus 8. So that's x1 plus x2. So that's q minus 8 over 2 like this. y1 plus y2, that's your y1 in this case, which is 3. Your y2 is minus 1, so it's 3 plus minus 1, which is 3 minus 1. So we've got 3 minus 1, 2 over 2 like this, which is going to give us the midpoint that we are given here, which is minus 7 over 2p. This is our midpoint already. So as we can see, it's actually an equation because this represents the value of x and this represents the value of x, which should be equal. These two, they are equal. So we can form an equation by that. 9, it's q minus 8 over 2, which is equal to the value of x here, which is minus 7 over 2. You do the same for y here. This is your y, this is your y. So definitely these two, they are equal. So 3 minus 1 over 2 is equal to p. So you can solve your equations just like that. Okay, so multiply by 2 here. This is gonna cancel. So q is equal to, we transpose this to the other side, so it will be minus 7 plus 8 because it was a minus, so it will be plus 8. And q is going to be minus 7 plus 8, which is same as 8 minus 7, which is 1. P here, 3 minus 1, that is 2 over 2, which is 1. So p is going to be also equal to 1. So p is 1 and q is equal to 1. So that is what we're having, guys, from the midpoint concept. All right. Then on 4.2, we are given that the vertices of a triangle, these are the vertices of a triangle or a OBC. Okay, then we are given that prove that x is equal to square root of 2 if B or C is equal to 90 degrees. Okay, let's just make a sketch, guys, of what is happening here. This point B is actually the origin, that's 0, 0 there, which is the origin. So maybe we have got let's just say we've got a Cartesian plane like this, so that we can actually understand what is happening here. So this is your origin here, which is where we have our point O, because this is our O here, which is 0, 0. Okay, then we have got the point B, which is square root of 2, square root of 2. So this is actually positive, just like 2, 2, maybe x is 2 and y is 2. You know that they can meet at a certain point. That is what you just do. So square root of 2 and square root of 2, it's a positive. So definitely it's going to be in the first quadrant. So that's our point B, which is square root of 2, square root of 2. So we've got square root of 2, square root of 2 like this, which is our point B. All right. Then there is another point, which is C, that we are supposed to prove that it is going to give us square root of what? 2x, because it's x minus square root of 2. But as we can see, it's in the negative because the value of y here is negative. So it's going to be somewhere in the negative. So I'm just going to put it here in the negative. All right. So this is our point C. So we have got something like this. If we adjoin here, this is maybe what we are going to have at the end, which is our C, which is x minus square root of 2. So this is the value of x of y here, which is minus square root of 2. The value of y there, which is square root of 2. The value of x here, which is square root of 2, something like that. Okay. So the question is, we want to prove that this x here is equal to square root of 2 if B or C is 90 degrees. If B or to C is 90 degrees like this, what does it mean like this? If this is 90 degrees, what does that mean to you? If that is 90 degrees, it means nothing, but we know that when this is perpendicular, because 90 degrees means perpendicular, it means this line here, OB, and this line, OC, their gradients must give us a -1. The gradient of line OB to the gradient of line OC, they must give us -1. The product, because this is perpendicular from a perpendicular lines here. If the lines are perpendicular, the product of their gradients gives us -1 from this concept here. Sorry. So that is what we have. So in this case, we have to find an expression for the gradient of line OB and line OC. So there we just have nothing because the line O here is 0, 0 there. So remember gradient, guys, x1, y1, x2, y2. So the gradient of OB, remember gradient is y2 minus y1 over x2 minus x1, okay, which is OB, y2 minus y1, that's square root of 2 minus 0. So you've got square root of 2 minus 0 over x2 minus x1, which is square root of 2 again minus 0, like that. So as you can see, these two are the same, so this is going to give us a 1. All right, we move on to the gradient of OC. So you're going to find this gradient of OC in terms of x. So this is your x1, y1, this is your x2, y2. So remember y2 minus y1, so it's minus square root of 2 minus square root of 2 minus 0 over x2 minus x1. Our x2 it's x and our x1 there is 0, so it's x minus 0, like this. So we can simplify this. Remember, when you're subtracting a 0, there's nothing, just like 2 minus 0 is 2. So minus square root of 2 minus 0 is minus square root of 2. X minus 0 is x. All right, so this is the gradient of line OB, the gradient of line OC. And we said the product of these should give us minus 1 if BOC is 90 degrees. So using this concept, we can calculate the value of x. All right, so we say the gradient of OB to the gradient of OC should give us negative 1. Okay, and we have got the gradient of OB, which is 1. So 1 times the gradient of OC, which is the gradient of OC, this one, minus square root of 2 over x. We must obtain negative 1. So we have formulated an equation by just knowing this concept, guys. Look at the advantage of knowing this concept. We have formulated an equation where we have to solve for x. All right, so 1 times any number remains as it is. So this is minus square root of 2 over x, which is equal to minus 1 over 1. You can cross multiply. Minus square root of 2 is x times minus 1, which is minus x. So you can divide by minus 1 to find x, which is square root of 2. So your x there is going to be square root of 2. That is the concept. So as we can see, this is what we proved, what we wanted to prove, that x is square root of 2. So this is our x here, which is square root of 2. All right, so that's what we had. All right, so as you can see, guys, that's how they ask these questions some of the times. Then other part is on question 3, which is now to determine the perimeter of the triangle, and we've got 4 marks for that. To determine the perimeter of the triangle, take note, this is our triangle here, and the perimeter means actually the distance right round the shape. All right, so which means we shall have from O to B, from B to C, and C to O. That is perimeter. Okay, so this is 4.22. So the perimeter is distance right around the shape. So I'm going to add O to B, that's OB, plus B to C and C to O. So it's BC plus CO, like this. All right, so which means we have to find the length of OB. So remember the length, guys, you have to use the distance formula, and the distance formula states that is the square root of x2 minus x1 squared plus y2 minus y1 squared, y2 here minus y1 squared, like that. All right, so I'm just going to write here, but for the others we are just going to put direct. Remember our OB, this was our x2, so it's square root of 2 minus 0, because we are referring to this line OB, so square root of 2 minus 0. All right, so it's going to be like this, square root of 2 minus 0 squared plus y2 minus y1, which is also square root of 2 again, so it's square root of 2 minus 0, like this. All right, so this is going to give you, as you can see here, square root of 2, this one, you can just use your calculator straight, but it's going to give you 2 squared plus 2 squared. Okay, 2 plus 2, guys, because this is square root of 2 squared, which is 2. So it's going to be 2 plus 2, which is square root of 4, which is 2. So OB is going to be 2 units, or you can just use your calculator direct, all right? We calculate the same, but I want you to cross-check something here for OB. This 2, they have the same value of x here, which is square root of 2 minus, and the same value of y. So these values of y are the same, which means this is same distance. We have got same distance here from this part, OC. So here, OC is equal to OB from that concept. So which means it's 2 units also. These are units. So we've got 2 units there. So there's no need for you to calculate that one. Okay. Also, this one, if we are to cross-check, if you have got a sketch like this, you are going to see that from B to C, this is a straight vertical line because we've got the same value of x here, which is square root of 2. So it means we just need the distance, because it's the distance from this point to this point, it's square root of 2 here. From this point to this point, it's square root of 2, even though it's negative, but it's square root of 2, the distance. So BC is going to be square root of 2 plus square root of 2, which is 2 square root of 2. That is your BC. So your BC is going to be 2 square root of 2, or you can use distance formula. You're going to obtain the same answer if you use distance formula, because it is going to take us time. But if you use distance formula, still it's gonna have the same answer. All right, so now our perimeter, we add everything. OB, we said is 2 plus BC, our BC, which is 2 square root of 2, plus CO, our CO, which is OC, we said is the same as OB, which is 2. So this is what you're going to have. So your perimeter is, if you add, you can just add these 2 plus 2, that is 4 plus 2 square root of 2 units. So this is perimeter. So you just put it as units. If it was area is the one that you put it as what? As square units, but perimeter is just the units as they are. So that is what you have, or you can simplify this as a decimal. It's going to give you 6,82 units if you put it as a decimal, or you can just leave it like that. Still, it's one and the same thing. So that's what we had, guys. So as you can see, maths, guys, it's all about also having sketch. Don't just answer a question like it's a theory question. No, this is maths, guys. So draw diagrams, a sketch, something else that helps you to answer the question. All right, this is gonna help you a lot. All right, on 4.3 we are asked to prove that the straight line 3y minus x minus 10 is equal to 0 is a tangent to the circle. Okay, the thing is, how do I prove that a line is a tangent? Okay, let me just draw a tangent here. Let's say this is a circle here and this is a tangent. So definitely there is no way, if this point is a tangent, it is going to meet the circle at one point. Okay, so a tangent meets the circle or a curve. It's the circle or a curve at one point. At one point only. That is the idea there. So that means if we are to solve, because look at this, if it is like this, like this, it's not a tangent. This one, it's not a tangent because it's going to meet at 2 points. But a tangent is just like this. That's a tangent. So remember, I am given the equation, so I can solve these equations simultaneously. And if I solve these equations simultaneously, I'm supposed to obtain one value of x and one value of y. That is to show that this is at one point. Okay, so let's prove that by solving, because we are given 2 equations, the first equation and the other equation. All right, let me just write them down. That's 3y minus x minus 10 is equal to 0. and the one of a circle, which is x squared plus y squared, which is equal to 10. So these are the two equations that we are given. So we are going to solve to see if this is going to meet at one point. We must have one point as our solution. We must have one point or one solution as our answer. That is to show that it's a tangent. Okay, it's only a tangent that can do that. Okay, so how are you going to do this, guys? Okay, this is equation 1, equation 2. Let's just make x here or y the subject. I don't know, but we can make x the subject because I can just take this to this side so that it can be a positive. So that means 3y minus 10 is equal to x, which will be our equation 3 actually, because this is equation 1, equation 2. All right, so if our x is equal to 3y minus 10, I can substitute this into the second equation, this one. So that means in place of x, I'm going to substitute 3y minus 10. So it's going to be like this: 3y minus 10 in place of x, then I have to square it, plus y squared equal to 10. So if I solve, I know that this is a quadratic equation where I'm supposed to obtain two possible values, but because it's a tangent, I'm going to obtain one solution. That is what it means. All right, how is this possible, guys? Okay, let's just expand our brackets. 3y minus 10 into 3y minus 10, that's 3y and 3y, 3 times 3, that's 9y squared. 3 times 10, which is minus 30y, minus 10 times 3, which is minus 30y, minus 10 times minus 10, which is plus 100. So you are going to have 9y squared minus 30 minus 30, which is minus 60y there, plus 100. All right, so we are going to have 9y squared minus 60 minus 60y plus 100. All right, plus y squared, which is already transpose this 10 to this side, is going to be minus 10 is equal to 0. So as you can see, we have formulated a quadratic equation. Let's just combine. Yes, same as 1y squared, so it's 9 plus 1, which is 10y squared minus 60y, like this. 100 minus 10, that is 90. Yeah, that is plus 90 is equal to 0. So we can just try and reduce this, maybe just reduce it by 10 by 10. That's gonna cancel here, which is y squared minus 6y there. This is gonna cancel, which is plus 9, and that's a 0 there. So as we can see, this is now an easier equation for us to solve, because you can just perform our factorization there. Y squared minus 6y plus 9 is equal to 0. Remember, this is 1 there, so you just need two brackets, equate them to 0 equal to y and y. So remember, we focus with 9 there. What are the factors of 9 which we are going to add to give us minus 6? So we've got minus 3 and minus 3 from 3, because 3 and 3 will give us 9. If we add this, will give us 6, not minus 6. We need something that is going to give us minus 6. So it's minus 3 minus 3. So as you can see, y is equal to 3, or y will be equal to 3. By just having this, it means I'm going to have the same value of x, because here I'm substituting the same value of x here, the same value of y here. I'm going to have the same value of x because our x is 3y minus 10. So if I substitute this value of y, which is 3, is the same value of y, which is 3. So there is no way I'm just going to have the same value of x again. I don't know the value of x that you're gonna have there, but it's going to be the same, which is something like 9 minus 10, which is minus 1. Yeah, which is minus 1. So you've got the same value of x, which is actually just like a point minus 1, 3, like this. So that means, therefore, the line is a tangent. Remember, that is what we wanted to prove, to say that if this is a tangent, our solution is going to be one point. If it is a point like that, which is one value, that means it is a tangent. So by just having this, you have proved. So there is a lot of ways that you can actually do, so many ways that you can have this. Okay, then determine the equation of the line through the point P, which is 2 minus 3 and parallel to the y-axis. So we need a line which is parallel to the x-axis, which passes through the point P, which is 2 minus 3. How can we have that line, guys? Remember, if a line is parallel to the y-axis, this is your y-axis like this. We've got the x-axis, the y-axis. So there's a point P, which is maybe 2 here, and minus 3. So these two, they meet at a certain point here. This is your point 2 minus 3, which is the point P. So a line that is parallel to the y-axis, we are referring to this line like this, that is parallel to the y-axis. That is a line parallel to the y-axis. So that line, it's a vertical line which passes through the point of x, which is 2. So it's the line for x, which is x is equal to 2. So that is the line that we are talking about there. So that is the line parallel to the y-axis. All right, then we are given there we are given a diagram where we are being given that in this part here, we have got the points, point A, point C, then the 3 points on the Cartesian plane. Then you are given the angle B, AC. Then B is in the third quadrant. Determine the equation of AB. So you need the equation of that line AB. All right, so definitely here we do not have something that is direct for now. Here we actually do not have anything that is direct that we are going to use to say that we are going to have this equation of a line. But let's just have this down. Maybe it's gonna help us. We have got something like this, guys. Take note here. All right, this is just theta here, and this is our point A. I'm gonna like indicate the most important part, which is going to help us, even though we might not even know the value of C, but the value of B there, but we can have something there. All right, this is what we just have, and we've got the angle here inside of 78.69. This is 78.69 degrees, which is the angle inside there. All right, and you want to find the equation of the line AB, which is this line here, AB. All right, we know that once we can have the gradient of this line, we can be able to find its equation, because already there's a point which passes through the line. As long there's a point and a gradient here, we can have the equation. But where can we find this now? Where can we find this gradient? Because we do not have any relationship between this line and this line. The only thing that we have for the gradient is this angle here. Let's say this angle, let's write it as alpha or beta. Let's just say this is our alpha here. It means that if I am to obtain this angle, I can be able to obtain the gradient of this line, because remember that m is equivalent to tan theta, which is tan alpha, which is the gradient. So I can be able to find the gradient, which is in this case m is for line AB. So I was actually supposed to write it like this, MAB, because I'm using alpha for this. This one is for theta, this one is there. So where can we have this angle alpha now? That is the question. So we need to find alpha so that we can find the gradient. So find alpha. So how can we end up with this alpha? All right, let's see some of the relationships that we have, because this one we can actually find it because it's an angle of inclination of the line AC. So which means we can work something from line AC. Okay, from line AC we can work out something. Let's find the gradient of line AC. so that we can obtain the angle theta, because there is angle theta there on line AC. So we have to find the gradient. Remember the gradient, guys. We talked about this: y2 minus y1 over x2 minus x1. So we're gonna have this is our C. So let's just put this as a x1 y1 and this as x2 y2. So it's minus 1 minus 2 y2 minus y1. So it's minus 1 minus 2. It's gonna be minus 1 minus 2 over x2 minus x1, which is 1 minus minus 1. So it's 1 minus minus 1. Okay, let's hope I'm not mistaken there. So this is going to give us minus 3 over 2 minus minus, which is a plus there, minus 3 over 2. All right. So by just looking at the line, it gives us a negative gradient, and also the slope of this line. It tells us this is an obtuse angle. This theta here is supposed to be an obtuse angle. So what you're going to do is to find the reference angle from this gradient. Remember, tan. We are going to have our reference angle, which is arctan, to find the angle. So you use arctan 3 over 2. Don't consider the negative. The negative is there just for the slope, to show you that it's an obtuse angle. So you find arctan using the positive, or you just use it no matter, you have to work from there. So this is what you're going to obtain. If you use this as a positive, you're going to obtain your reference angle as 56,30 whatever, which is 56,123. This is gonna change into 10 and gives us 1 here. So it's gonna give us 310 degrees, which is just 31. All right. So this is your reference angle, guys. When I say the reference angle, I mean the angle which is the acute angle. That is your acute angle. So the acute angle, you ignore the negative, this one. So therefore theta, remember we want to calculate theta from line AC. We want to calculate theta. So therefore our theta in this case, because we talked about the reference angle which is on a, so this is it, this one, this is your theta, this one, the one you want, what you want. So actually you calculated this one, but because it's gonna confuse us if I talk about this, so let's just write this, our theta, which is gonna be 180 angles on a straight line. So it's 180 degrees minus 56,31, which is gonna give us something like 123,69 degrees. This is what you're going to have there. So this angle that we have obtained of 123,69 degrees, this is the one here outside of the diagram here, which is 123,69 degrees. So as you can see, there was no need of us having this, because we still have to subtract again from 180 to find this angle inside the shape, this one, which is this 56, because if you subtract from 180, you come back here to this 56,31, like this. So this is it, guys. We are now at this stage. Remember, our main aim is to find alpha, because we want to have the gradient of line AB, which is connected to alpha. So now we are able to find our alpha. How are we going to find this alpha? Remember, this is a triangle. Angles in a triangle add up to 180. So we subtract all these angles from 180, which is 180 minus the two angles, these ones, you just combine them together, 78,69 degrees plus 56,31 degrees, like this, and this is gonna give you 45 degrees as your alpha. So at least now we know that this angle is 45 degrees. So how is this going to help us? Remember, the purpose of finding alpha is that we can have our gradient, because I said gradient is equal to tan alpha. So the gradient of line AB, which is the line that we want to find, its equation is equal to tan alpha, which is tan the angle of 45 degrees. And this is going to give us a 1, right, from our calculator. So we have the gradient of line AB, guys. We just obtain this gradient of line AB, which is 1. So we know that when we've got the gradient and there's a point, because A is a point on AB, so we can utilize that one to find the equation. How are we going to do that? Remember, the equation of a line is given by the equation y is equal to mx plus c, where m is the gradient. So we've got a gradient of 1 there, so y is equal to x plus c. So to find the value of c, we then now substitute our point A with the coordinate -1, 2, where x is -1 and y is 2. So y is 2 when x is -1 plus c. So transpose this is going to be plus, which is equal to c. So c is equal to 3. So therefore, y is equal to x plus 3 is going to be our equation, because we are substituting here. So guys, as we can see, these questions, some of these you have to play around everything that you know about the concept of the question, the typical, how you relate the gradient and angles. It's not about just you are given points direct like that. No, it can't be like that. Some of the questions you have to play around, like what we had on this one. Then on question 5, you're now asked to sketch, you want to make a sketch of 25 x squared plus 4y squared, which is equal to 100 in answer book. Okay, this one is just a sketch, guys. Let's just see. And also, when you are working with a sketch, you are supposed also to just have like an idea of what's going to happen, the type of a function or a graph that you're going to have at the end. As you can see, this one is actually an ellipse, where we have to find just x-intercept and the y-intercept. Okay, so you've got the x-intercept, where we know that y is going to be equal to 0 at that moment. So if y is equal to 0, definitely this piece is no longer there. You are just going to be left with this part. So it means 25x squared is equal to 100. All right. So to find x, just divide by 25 by 25, which means we are going to have x squared, which is equal to 100 divided by 25, which is 4. Square root both sides to find x, which is plus or minus 2. All right, so that is what we have for x. And having the same concept, you are going to do this for the y-intercepts. All right, which means x is equal to 0 this time. So this piece is no longer there this time. You're going to be left with 4y squared, which is equal to 100 divided by 4 by 4. That's gonna be y squared, which is 25. 100 divided by 4, which is 25. So square root both sides, y is going to be plus or minus 5. So you've got the x-intercept and the y-intercept, guys. You have our Cartesian plane. We just mark x and y there. So x, as we can see, x is at plus or minus 2. So when x is 2 and minus 2, so this is 0. Let's just say this is our 2 and this is our minus 2. And y is plus or minus 5 in the y-axis, because y-intercept is in the y-axis. So it may be plus 5, it's here, and maybe minus 5 is there. So as you can see, it is not supposed to be equal to this one. It's supposed to be bigger, because 5, guys, is somewhere. All right, so this is what you're going to have. And this, we said it's an ellipse, so you are just supposed to know at least the typical sketch that you're going to have at the end. So just an ellipse like that. So that's what we have, guys, for this ellipse of 25x squared plus 4y squared, which is equal to 100. So these points are the ones which you're supposed to be very, very careful with. This supposed to be indicated, the x-axis, the y-axis, and also the equation of the function or the equation of the graph that you are drawing there. All right. So that's what we had. And the other part, let's just quickly work on it, where we are asked there to determine divide x of the following function using the rules of differentiation. Leave the final answer with the positive exponent and in set form. So we need to leave our answer with the positive exponent and in set form, and that's what we had. So let's just quickly have this. This is a 5.2 where we've got y, which is equivalent to square root of x over 4 minus 1 over 4x squared, like this. All right, so the first thing before you do you perform your derivatives is to first rearrange and make sure that you can have it in a way that you can be able to find the derivative. So x square root of x, remember, is same as x to the exponent of half over 4 minus this. We have to write it on top here, but it will be having a negative exponent like this, because remember this is same as 1 over x squared. We want to write the x on top so that we'll be able to differentiate it. So it's x to the exponent of minus 2 over 4. Take note, 4 is not to be affected. There's nothing that has to do with 4 there. All right, now we can find, here we're just rearranging. Now we are going to find our dy dx. So what are we going to have on our dy dx? Remember, we have to drop the exponent, we multiply by the exponent, then we subtract 1. Okay, so here our exponent is going to be half times, what are we going to multiply? We multiply to this 4, which is 1 over 4, because it's in the denominator, so it means it's 1 over 4. Okay, then x is going to subtract, so half minus 1, this one it's half minus 1, which is minus half. Okay, so this is just x to the exponent of minus half, like that. All right, you do the same here. It's minus, here there's a minus, so you drop the exponent, which is minus 2, so it's going to be minus 2 times this part here, so it's going to be x to the exponent. You remember, you subtract 1, so it's going to be minus 2 minus 1, which is minus 3 over 4. There's a 4, so this one is same as like over 1, like this. All right, so that's your dy dx. Here you just now try to write in a simplest form, so you can multiply 1 times x, which is x to the exponent of minus half, 2 times 4, which is 8, minus times minus, that's a plus, so this gonna cancel. Remember, 2 and 4 can cancel, which is over 2. So you can have x to the exponent of minus 3 over 1 times 2, which is 2. So you can actually simplify further like that. And we know that we can now rewrite, remember what we had here when it was 1 over 4 x squared, we wrote it as x to the exponent of minus 2 on top. So we can do the same because it has a negative exponent, so we write it in the denominator. Okay, so this is our dy dx, which is going to be 1 over, because we have a negative, so we're going to be 1 over, we write this in the denominator, so it's 8 times this, which is 8x to the exponent of a half. All right, plus we do the same, this is negative 3, so we write this down here with a positive exponent, so it will be 1 over 2x to the exponent of 3 with a positive exponent, like that. So that's how you remove the negative. But remember, the instruction is not only to leave with positive exponents, but also in set form where it's necessary. So here we can leave this answer in set form. Remember, square root of x, x to the exponent of half, is same as what? As square root of x. So this is what you're going to have at the end. So as you can see, there's actually nothing I can do further than that. Here there's nothing, so that's how you could have taken 5 marks there. That's how you're supposed to take these 5 marks, which is this part. Okay, then we have on 5.3, which is actually derivatives there, because we are given that the fig shows f of x, this is f of x, a and b are the turning points, so a is a turning point, b is a turning point. Okay, so this is the x-intercept, and here, as you can see, this is a turning point and it's a solution, so which means here it means that there are 2 solutions here. All right, so prove that the values of b is minus 9, c is equal to 9. All right, so That's what I'm going to use the solutions here. Remember, if you've got because this is where you've got your f of x here. All right, so our f of x is given by x cubed here plus bx squared plus cx. Remember, it was supposed to be f of x is equal to ax cubed plus bx squared plus cx plus d, like this. So which means our d is totally s0 there, and our a is a 1, because that is why it's not given. This is a 1 here, so our a is a 1. So we need to find this b and c. So we remember, when you are given solutions like this, you are given solutions, you can actually formulate this f of x from the solutions. It was supposed to be f of x is equal to a into x minus x1, x minus x2, x minus x3, which are these are the x-intercepts. All right, so in this case it's going to be a, and our a, we said it's 1, so it's going to be 1 into x minus, here at 0, here the value of x is 0, so it's going to be x minus 0 into x minus the solution here, the value of x at b is 3, so x is 3. So this one is supposed to be minus 3, but it's a turning point, which means there are two values here, so it's supposed to be like this, x minus 3 squared. That means it's a turning point and a solution, so it's supposed to be squared like this. All right, which means there are actually two brackets there like this. It was x minus 3, x minus 3, like this. That is what it means. All right, so now we want to expand, so that if we can expand this, which means we can have our equation like this, so that we can state the value of a and the value of b. So we have to expand to that format. So let's just put our expansion, guys. 1, there's no need of us writing, but x minus 1 is x, so 1 times x is x into this bracket of, so you can expand this, that's x and x, which is x squared, x and minus 3, minus 3x, minus 3 times x, which is minus 3x, minus 3 and minus 3, minus 3 times minus 3, which is 9. So you're going to have x squared minus 3 minus 3, which is minus 6x plus 9. All right, so this is what you're going to have from this bracket of x minus 3 squared. You're going to have x squared minus 6x plus 9, like this. Then we can expand by x times x squared, that's x cubed, x times minus 6x, which is minus 6x squared, x times 9, which is 9x. Okay, so take note, this is our f of x in the expanded form, where we can equate now to that f of x that we were given. Remember, we are given that f of x is equal to x cubed plus bx squared plus cx, like this. So we can tell that from these coefficients of x squared, this one with x squared, b is equal to what? Minus 6. That is what we have. We can even tell c is equal to the part with x here, the part with x. So c is equal to what? C is equal to 9. So that's what we have, guys, from this expanded f of x. It can give us a lot. So as we can see, that is what we were being asked to prove or to show, because the question was for us to prove that b is minus 9 and c is b is minus 6 and c is 9. Then determine the coordinates of the maximum turning point a, which is this one. So we know that we are given the two turning points b and a, and as we can see, b is the minimum turning point and a is the maximum turning point. And about the turning points, we actually know that here there's nothing, but we know that at the turning point, the first derivative should be equal to what? Should be equal to 0. So we can just find the first derivative since our f of x is there. So since we have got our f of x, which is now x cubed minus 6x squared plus 9x, we can just find the first derivative and equate to 0 at any turning point. At any turning point, this is what you're supposed to know. All right, so if this is what happens at any turning point, therefore let's find our first derivative. which is 3x. We subtract 1 here, which is 3x squared, minus 12x. Remember, 2 times 6, which is 12. Subtract 1, which is minus 12x plus 9. And we are saying at the turning point, this is equal to 0. 3x squared minus 12x plus 9 should be equal to 0. So it's now an equation which you can just solve by reducing the equation. X squared minus 4x plus 3 is equal to 0, like that. So you've got two brackets that you're going to work with equal to 0 there, where you've got because the quotient of x squared is 1, so you just have x and x. So what are the factors of 3 which are going to give us minus 4? Factors of 3, so they're definitely minus 3 and minus 1. So you've got minus 3 minus 1, so equating x to that side is going to be positive 3, or x is going to be 1. But there's something that is happening here. If we are to cross-check on this part here, already there's a turning point which is at 3 here. So definitely x can never be equal to 3 because it's already one of the turning points. So our a is going to be left with 1. So that is the value of x at point A, but we want the coordinates, which means it's a point, that one, where we are saying when x is 1, therefore what about the value of y? To find the value of y, we substitute into the original f of x here. We substitute x, which is equal to 1. So that's 1 to the exponent of 3 minus 6 into 1 squared plus 9 into 1, like that. So you have to substitute, in place of x, you substitute 1, just like that. Okay. So by doing this, we are going to obtain the value of y, which in this case is going to be 3. Is that so, guys? 3, that's minus 4, something like that, which is a positive, because this is going to be 10 minus 6, which is 4. So our y is going to be 4. So therefore, the point A, which is the turning point that we are talking about here, this point A here, which is a turning point, is going to be 1, 4. It's a point, so the value of x is 1, the value of y is 4. That is what the question was asking you to do. All right, then on question 6 we have a question. Okay, that's question 6 exactly. So that's the last part actually. Use the trigonometric identities to prove that. We want to prove that this left hand side is equal to the right hand side. All right, so how are we going to go about this one, guys? This is 6.1, we are given 1 minus sine theta minus cos theta squared, like this, everything over sine theta. All right, this is what we have, which is going to give us 2 cos theta, like that. All right, so I want us to cross-check something here. This part is actually simplified, so there's nothing that we can actually do much. So I'm going to choose to work with the left hand side in this case. All right, so working with the left hand side, as we can see, we have got this part here, 1 minus sine theta minus cos theta squared, which maybe we have to first expand. So we're going to work from the left hand side, so it's going to be 1 minus, let's just expand this separately, guys. Sine theta, yes, we can just use the identities to expand this one, but most of us, now that's the problem. So let's just expand like this. All right, so it's gonna be sine times sine, which is sine squared theta. Okay, then sine and minus cos, so it's minus sine theta cos theta, like this. Okay, we are done with sine. So it's now minus cos and sine, so you write it like this one. So it's minus sine theta cos theta, so that you don't confuse yourself there. All right, then minus cos theta and minus cos, that's minus minus, which is a plus, so it's plus cos squared theta. All right, so that means these two can be collected together, which is minus 1 minus 1, because these are like terms. So you're going to be left with sine squared theta minus minus 1, which is minus 2. So it's minus 2 sine theta cos theta like this, plus cos squared theta at the end there. This is what we had, this one, plus cos squared theta. All right, then everything over what? Over sine theta. So this is another stage that we are now. All right. Now there's something here. We know that from our identities, sine squared plus cos squared gives us a 1. All right, sine squared theta plus cos squared theta gives us a 1. This is same as cos squared plus sine squared is 1 and the same thing. So we are going to have 1 inside there. So this is going to be 1 minus inside the bracket. This 2 gives us a 1. But we have got minus 2 sine theta cos theta, which is still inside, which is you have to write as it is over sine theta. That is the stage that we are now. All right, let's just expand our brackets, which is 1 minus times 1, which is minus 1, minus times minus, which is a plus. So you've got plus 2 sine theta cos theta like this over sine theta. All right, so 1 minus 1, actually this is going to cancel. So this is what you're going to be left with, which is going to give us 2 sine theta cos theta everything over sine theta. All right, so cancelling this, you are going to be left with this cancels is 2 cos theta, which is the one that we are given, or the one that we have on the right hand side. So as we can see, this is actually the same as what we have on the right hand side. So that is what we just needed there, guys. From that part, that is what we just needed. So as we can see, guys, that's how they ask around this question. Then on 6.2, we are therefore given that part on 6.2 where we have calculate the values, or the value of theta. So these ones, they are going to satisfy from 0 to 270. All right, okay, this is what we have here. We are given 6.2, which is actually square root of 3 tan theta plus 10 degrees like this, which is equivalent to 3. All right, so remember the interval that you're given, 0 to 270, is actually like this. Remember your quadrant here. Remember your quadrant here. This is 0, 90, 180 to 270 and 360. So which means we are working with this quadrant, and this quadrant. Okay, so the first thing, guys, let's just maybe remove all these parts which are affecting. Divide by square root of 3, divide by square root of 3. Okay, cancel out this. That's tan theta plus 10 degrees equal to 3 over square root of 3. Okay, so remember what I always say about the reference angle, guys. There's this reference angle. You're supposed to understand a reference angle. Reference angle is the angle that you find by calculating the acute angle of the quadrant, because we're talking about the quadrant of tan, where in this case from our quadrants, we are going to work with these quadrants here. All students take calculus. So as you can see, we've got all and tan. So these are the quadrants that you're going to work, the first quadrant and third quadrant. So this is where you're going to have your reference angle and your reference angle here. So the reference angle is simply arctan. That's our reference angle. It's going to be arctan 3 over square root of 3. That's your reference angle, which is in this case is going to give you 60 degrees. All right. So this is your reference angle, which is the angle that you're going to use now to find the actual values. So the actual values now, we are saying we have got the first angle in the first quadrant. So in the first quadrant, your theta is equal to the reference angle here. It is equal to the reference angle. In the third quadrant, your theta is equal to 180 degrees plus the reference angle. All right. So that means we are going to take this now and equate to the angle in the first quadrant, which is theta plus 10 degrees is equal to the angle that we obtained in the first quadrant, which we said is equal to the reference angle, so we take as it is, which is 60 degrees. Or another one in this quadrant, because we are still in the interval, this one we said theta is equal to 180 plus the reference angle. So that means this part here with theta plus 10 degrees is going to be equated to 180 plus the reference angle. This is your reference angle here of 60 degrees. So it's going to be 180 plus 60 degrees, which is your reference angle. All right. Now we can solve for theta. That's 60 minus 10 degrees, which is 50 degrees here, theta. Or here we can, theta plus 10 degrees is equal to, first combine this, which is going to give you 240. So your theta is going to be transposed to that side, is going to be 240 minus 10, which is actually 230. Is that so, guys? 230 degrees. Okay, just cross check, guys, with your calculators also to see if we are saying the same thing or if we are obtaining the same thing there. Okay, then another part, let's just see here, which is we are given, okay, it's actually a continuation from this statement here. We are given this statement. So actually, guys, this statement, when it's like this and the diagram is drawn, it means nothing, because they have drawn the diagram for us. The information is there. So what you need is to calculate the length BD and the length DE. All right. So how can we calculate the length BD and the length DE in this case? Okay. So this is it, guys. First try and work out your triangle. Find any possible angles that you can actually have from that diagram that you have. Find any possible angles. Okay, as for me, I'm going to calculate this angle here. All right, so that angle there in B, remember that angles on a straight line, they add up to 180 here. So because we want to calculate this line BD, so at least let's try to fill in this triangle. Okay, so this is going to be, this is your 74, this one. So it's going to be 180 minus 74. And 180 minus 74 is what? 106. Let me just write it here. So this is going to be 106 degrees there. All right. Also, we can find this angle here at D. All right. Remember, angles in a triangle. Angles in a triangle, they add up to 180. So we can calculate ADB. Okay. Which is our ADB is going to be 180 minus these two angles in a triangle, which is 43 and 106. So it's 43 plus 106 there, which is going to give us something like okay, this is 31 actually, something like 31 there. All right, so this is going to give us 31 degrees. All right, that's 31. Okay, another thing, so which means using this information we can calculate this line BD. Okay, remember we have got a line and an angle here. The side and the angle, they are opposite to each other, and this side here is also opposite to this angle. So you can actually apply sine rule. Sine rule works when you've got side and angle, side and angle, side and angle. Yes, so you can apply sine rule. Remember your sine rules test that okay, let me just write it here. This is our 6.3. It says that A, so we want to calculate BD first. We want to calculate BD. All right, so it says that A over sine A is equal to B over sine B, which is equal to C over sine C, something like that. Okay, so here we need this BD is the one that you want to calculate. So it's BD over sine the angle which is opposite, which is sine 43. So it's BD over sine 43 degrees, which is equal to the other side, which is AB over sine 31. So it's AB, we have it, so you just have to write it AB, which is 500 instead of writing AB. So let's write 500 over sine the side, which is 31, like this. So I can actually calculate BD, remove this sign, multiply by sine 43 both sides, multiply by sine 43 degrees both sides, so this gonna cancel. So BD will be equal to this one, and this one cancels. No guys, no, this one cannot cancel, sorry. 500 sine 43 over sine 31. It's only this side here which cancels. Yeah, the mind, remember the mind guys will be so tired. Okay, but that is what you're gonna have here. All right, so you just use your calculator there to simplify, and this is gonna give us something like 662.085 381, something like that. Yeah, 381. And this 8 cannot, like this 662 to 3 decimal place, which is comma 123, which is 085. Yeah, that's our BD. And remember, this was, the other units are in meters, so this will be in meters because this is in meters. Okay, so now BD is there, and the other part was to calculate DE. So take note here, we need BD and DE. So DE, which is this piece here, we need to calculate this D to E, this one. Okay, so what do we have on this triangle? We only have this length of BD. Okay, so let's just take it this way. We have got something like this here. This is what we have actually. Okay, something like this. All right, so this is our B and this is our D. I just want to take this part here, B to D. We calculated this one, BD. It's now there. We said it's a 662. It was 662. Okay, 662 comma 085. That's 085 here. All right, meters. And we can calculate this angle here, which is in between here. Remember, this from this point to this point is 68, and from this point to this point is 74. So this small angle here is going to be 74 minus 66, not 68. This is 66. So 74 minus 66, which is going to give us 8 degrees. So this one is going to give us 8 degrees. So you've got 8 degrees inside here. All right. Then another thing is that we can obtain also this angle at E, and we can also obtain this angle at D there. All right, so all those angles we can actually obtain them. So this one at C, we can, since we said this is 8, we can add this to 8 plus this 106, which is going to give us 112 here. So it's 180 minus these two angles to find this one, which is 43 plus 112. So it will be 43 plus 112 like this, which is going to give us 23 degrees. So this will be 23 degrees here. So this angle will be 23 like this. Okay, remember this is our E. So at least we can calculate our DE now, because we have got the side DE that we want to calculate, and it is opposite to this angle. So you can apply our sine rule again. So to find DE, we can apply our sine rule again, which is DE over sine this side, this angle here, sine 8, which is equal to, we are given this side over and this angle here, so it's 662 comma 085 like this, over sine the angle which is opposite to the side. So take note, the sine rule, the side and the angle should be opposite to each other. So it's sine 23 degrees. Okay, so that's the stage that I have, and I have to remove this to find DE. So I have to multiply by sine 8 degrees here by sine 8 degrees. So this is sine, guys. Sine and sine cancels. You're going to remain with DE, which is 662 comma 085 sine 8 degrees over sine 23 degrees like that. All right, so okay, sorry guys, that's something like this. All right, so simplify that part. You're going to obtain 235 comma 825 235.650 something like that, which is 235.826 meters. So that's our DE. So that's what we had, guys, on this DE and the stages, and you've got 7 marks for that. And I don't know, maybe it's necessary, but some of these questions, I don't know how they put around them and the marks. If it is okay, then let's work on it, guys. And 6.4, we are given fig E below, representing the graphs of f of x, which is cos ax, and the graph of gx, which is b cos x, where we are given the interval from 0 to pi. Then determine the values of a and b. All right, so the value of a here is on cos, which is on f, and this is our f here. As you can see, this is actually from this point, which is 1 here, to this point, which is -1. It's actually half a cycle from pi. If we are to complete this like this, it is going to complete its full cycle at pi. So which means the period of this one is at 1, so it's at 360 degrees, so our a is going to be 1. Remember, if you have a period of 1, your a is, if you have a period of 360 degrees, your a is 1. All right, then the b here, it means the amplitude of cos x on gx, this one. If this is 1 here, this is at -1. So as you can see, it has an amplitude at -1 here, so our b is going to be -1, which is the amplitude. All right, so that's what we had, guys, to take a total of 17 marks on question 6 and a total of 100 marks from the whole question paper, like as you can see. So that's how they ask these questions, and what you're supposed to do is to give it in time to work out full papers, so that you'll be able to, at least, to know the areas that you are now good at, because with the time that we are having, we do not have time. So which areas are you good at? Work on those areas. That is the best thing that you can do for now. So that's it, guys, from African Motives. Till we meet again.